Hey everyone, welcome back to another Move Off the Data Math Tutoring to Go IM1 video. Today we're going to be talking about solving linear systems, particularly by substitution. This video is going to be part of a set where we're going to talk about two different methods of solving linear systems algebraically. So one is by substitution and one is by elimination. And this video is going to be focusing specifically on substitution. So let's get into it. Okay, so before we get into some examples, I just want to go over some of the steps of solving systems of equations using substitution. So as you may know, when you're looking at a system of equations, you'll usually be given two separate equations, and each equation will typically have two unknown variables. And we're going to be going over the steps that you would take in order to get numerical values for both of those unknown variables. So step one is you're going to isolate one of the variables, and that's usually going to be x or y, or it can be, other variables, and you're going to just pick one or the other in one of the equations and isolate them. And we'll get into more of how that'll look in an actual example shortly. So step two, after you isolate your variable, you're going to take that expression and you're going to substitute it into the other equation. So whatever equation you didn't use originally in step one, you're going to substitute your expression from step one into the other equation. And then step three, now after you've done step two, you should only be dealing with one variable. Once you've substituted the expression into the other equation, you should have one variable that you're solving for. So you should be able to solve that, and then you should be able to substitute the result of step three into either of the equations in order to solve for the other variable. So I know that's a lot of steps, and it'll make a little bit more sense when we get into some examples, so let me show some of those to you. Okay, so now we're just going to get into how we can actually apply the steps that I talked about previously. So looking at this example, we have two different equations. So like I said previously, step one is going to be picking one of those equations and isolating one of the variables. So I'm going to start with this top equation because looking at the equation, I can tell that it's going to be pretty easy to isolate x since there's no coefficient, and I should just easily be able to bring 3y over and get that by itself. So I'm just going to write x equals, or I'm going to say 6 minus 3y if I were to just subtract 3y from both sides. Okay, so that's step one. Now I've isolated my variable x. So now that I've isolated x, I can look at my other equation. So my other equation is 2x plus 8y equals negative 12. Since I have this x right here, and I determined previously that x equals 6 minus 3y, I can plug this expression right here into the x value in my other equation. So that's going to look like 2, 6 minus 3y plus 8y equals negative 12. And the purpose of this is to create an equation where we only have a single variable so that we can find a single numerical value without finding a solution that has more unknown variables in it. And that way we can plug that answer in later on to find the value for x. So if we were to solve that, this is going to give us 12 minus 6y plus 8y equals negative 12. Excuse my handwriting, I'm trying to write on my computer. So that is going to give us 12 plus 2y if we were to combine these two. And if I were to subtract the 12 from the other side, that's going to give us 2y equals negative 24. And I know I did a couple of steps in there, but all I'm doing is combining these two like terms, negative 6y and 8y, to give us 2y, and then I'm subtracting 12 from both sides in order to give us negative 24. And then if I divide that whole thing by 2, that's going to give us y equals negative 12. So now I have my first variable. Okay, so now that I've found my y value, I'm able to use this value to solve for x. So Now, I know that y equals negative 12, and I can use that value and I can plug it into one of my original equations. When you're doing this step, you can pick either equation, either of the original equations, and since they're in the system, it should give you the same answer. But I'm just going to pick the first equation just because this looks a little bit more simple and looks like it'll be a little bit easier to plug in. So, I'm going to look at this and I'm going to say x plus 3, and then in parentheses, I'm going to put negative 12 because we just figured out that y equals negative 12, so in place of y, that is what I will be writing. Negative 12 equals 6. So that's going to simplify to x minus 36 equals 6. And if I were to add 36 to both sides, it's going to give me x equals 42. Okay, so now I have both my x and y value. My y value is negative 12 and my x value is 42. Now I can put that into a single coordinate, which is going to give me 42, comma, negative 12. So that would be the point at which these two equations would intersect, and that's my solution to my system of equations. Okay, we're just going to do one more practice problem just in order to reinforce these concepts and make sure we really understand. We're now going to look at another system of equations. It's the exact same concepts. These equations are just a little bit more complicated with some more coefficients, making it a little bit more difficult, but still very manageable. So we're going to start off with the same step, which is picking one of our equations and isolating one of the variables. I'm just going to pick this top equation because I can tell by looking at this that they do have a common factor that I can divide by. So looking at this, I know that I can isolate my y value. I could also isolate my x value, but if I were to isolate y, then I can divide the whole thing by 2, which is going to give me all integers and no fractions, which makes this a lot easier to solve. So in order to do that, I can subtract 4x from both sides. That's going to give me 2y equals 14 minus 4x. And like I said earlier, I can just divide all of this by 2, and that's going to give me all whole numbers. So that's going to give me y equals 7 minus 2x. Perfect. So this is just the exact same thing as this equation, just simplified so that we're isolating just my y value. And again, I could have done the same thing with the original equation and isolated my x value, or I could have picked the second equation and isolated my x or y value. But looking at this, I could just tell that this would be the most simple path to go through. So that is what I decided to do. But you're more than welcome to choose whatever way works best for you. Okay. So now that I have isolated my y value, I'm going to plug this into the other equation that I did not use in the previous step. So that's going to be the 3x minus 5y equals negative 22. So I can say, since I found my y value, I'm going to be plugging in this solution just in place of y. So I'm going to say 3x minus 5. And then in parentheses, this one's going to be a little bit more complicated than last time because we have a whole expression rather than just a single value for y. So it's 7 minus 2x. Sorry, my board's not working very well. Equals negative 22. So to simplify, that's going to give us 3x minus 35 plus 10x, I apologize for the very messy handwriting, equals negative 2. So on this side, I can just combine like terms, and while I'm doing that, I'm also just going to bring this 35 over to the other side. So that is going to give me 13 on this side, so I'm going to have, if I combine these like terms, that's 3x plus 10x, it's 13x. And then if I were to add 35 to both sides, it's negative 22 plus 35, which also gives me 13. So that works out very well because I can divide both sides by 13, giving me x equals 1. Okay, so now I have my x value equals 1, and I have my y value equals 7 minus 2x. And since I know that x is 1, I can just plug that right back in here to say that 7 minus 2, and then my x value, I'm replacing 1 with x, is going to just equal 5. So my y value is 5, and I'm just going to write another, I'm going to write y equals in front of that. So my y value is 5, and my x value is 1. So if I put that into a coordinate point, it's going to give me 1, 5, which is where these two equations would intersect. Thank you all so much for watching. Please stay tuned for future Move Off the Data Math Tutoring to Go videos. In our next I'm One video, we're going to be covering a similar topic, discussing solving systems of equations using elimination. So if you're interested in doing a similar topic, but maybe using an alternative method, then that's definitely a video that I recommend checking out. If you have any suggestions for topics that you'd like to be covered, feel free to reach out to Mr. Collins or one of your Move Off the Data officers. Thank you for watching. I'll see you in the next video.